So hi everyone. So today I am going to explain magic squares in grid problem. So first of all, going into the problem, first of all let's understand what is a magic square. So a magic square is a three by three matrix. Sorry, my drawing is not good. It's a 3 by 3 matrix in which every it's an integer matrix. So every integer inside this 3 by 3 matrix must be distinct number, and also the number should range from 1 to 9. So it is a magic square. After satisfying these conditions, then the uh, sum of uh, sum of elements in each row, like first row, second row, third row, and each column, first column, second column, third column, and diagonals, this one and this one, these sums must be equal. All of these sums must be equal. Let me erase this. So that's pretty much it. A magic square is a 3 by 3 grid filled with distinct numbers from 1 to 9, and each row, each column, and also diagonals must have same sum. So in the given question, we are given a row into column grid of integers. So also this grid contains numbers from 1 to up to 15. So for in our magic square, we can have only 1 to 9, but in the given matrix or grid, we have numbers from 1 to 15, up to 15. So we have to take sub 3 by 3 grids from the given grid. So the the first grid we are going to consider is this one. Sorry if it is not okay. This one we have taken it out, and we have to calculate the row sum, like this row. Here it is 15, 15, 15. Again same for columns, 15, 15, 15. Yeah, also same with the diagonals. This sorry, it's not good. This diagonal and this diagonal, both sums up to 15. You can do that. And in the next example, here the row sum is 15, 15, 15, 15, 15, 15. But here, see, you can see the diagonal sum is not 15. uh, 3 1 2, it is essentially 6. So it is not equal. So since this is not a magic square, so we have only single magic square, that is we have written as output. So here in the second example, we have a grid of element 8. So the minimum requirement for a magic square is it should be 3 by 3 matrix. Since we do not have 3 by 3 matrix here, we can simply return 0. So okay, now let me explain clearly with example. Okay, we'll consider this. So what we have done, first of all, we have to take a subarray of 3 by 3, size 3 by 3 from the given matrix, and then we have to check each and every element in the matrix if they are less than or equal to 9. That is, the given matrix can contain numbers from 1 to 15, but our magic square should contain numbers from 1 to 9 only. So this is the first thing we check in the subset of 3 by 3 grid. So we'll check if the numbers are less than or equal to numbers are between 1 and 9. If they are not, we can simply return false, since the false. After that, we have to check each and every element is unique. That is, we have distinct numbers like 1 2 3 4. Like, we have to check the elements in this 3 by 3 matrix are distinct. That's the next thing we do. Let me write. Sorry, let me erase everything. uh, Let me write down. First of all, what we have to do, first thing we have to do is take take a subgrid of size 3 3 by 3 3 by 3, and then what we have to do in the second step, what we have to do, check numbers are numbers are between 1 and 9. So this is the next condition. If from here onwards, if any of the condition fails, we'll simply return false, because that subarray cannot be a magic square. And the third condition will be check all numbers are distinct. All numbers are distinct in subarray, subarray, whatever. And then next one is sum sum every 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 row, like, and if if sums are not equal, return false. Since the condition of the magic square grid is the sum of each row must be same, and sum of each column must be same, and sum of each diagonal should be same. So then we check the sum of each row is equal or not. Similarly, sum of each column is equal or not. Column is equal or not. Same with the sum sum of each diagonal. That's pretty much it. So let me go into the coding and start doing this. Okay, expand my coding. Okay, we are given a function, we are given a grid. So first of all, let me extract the size of the. Also first initialize the answer that we are going to return. I'm initializing it with 0, and we'll return the answer at last. Return answer. And before that, let me calculate the size of the grid. So m equal to grid dot. Now we have to iterate through the given grid. So I'm initializing a for loop int with row equal to 0, and we have to, every time we have to consider a 3 by 3 matrix. See, like this, if the current row is 0, then we have to consider up to row 0, 0 plus 1, 0 plus 2, from 0 to 1. That is we have to consider rows from row plus 2, and this should be in the bounds. This should be less than m, the size of the rows in the grid, and we increment the row. Now similarly for the column, we'll initialize it from 0, and we have to increase columns on 0 column, first column, second, similar to the row. Col plus 2, and also it should also be in the limits of the grid. We increase the column. Now the next thing, we have to check if it uh, uh, now with this for loops, we are getting the subarray of size subgrid of size 3 into 3. Now we have to check if it is a magic square. Now I'm going to call a function magic square. It will essentially return true or false. uh, True or false. I'm gonna call this function is magic square. because it will return a true or false whether the, and will pass the coordinates to this grid and row comma column. So if is magic square returns true, then we have to increment our answer by 1, because this particular 3 by 3 grid we are considering is a magic square, and then we have to check for next time next other grids also. So that's why, and at last we are returning it. So now we have to create the function is magic square. Let me copy this and create a new function, public, and we are going to return a boolean out of this function, and this function is going to take a 2D array of name grid comma in row and column as input, and then also so the first sorry the first condition we have written is check numbers are between 1 and 2, oh 1 and 1 and 9. So we have to go through the provided 3 by 3 grid equal to I less than 3, since the size will be of 3 I plus plus. This will be row, and same with the column. Say equal to 0, j less than 3, j plus plus. And we check if if grid of I comma j is less than or equal to 9, or grid of I j greater than or equal to 1. This should be the range. Or we can do it reversely. If the given number is given given position has number greater than 9 or less than 1, we can return false. Also yeah, this is it. And also next one is check all numbers are distinct. Okay, in this particular grid of 9, we have to check if all the numbers are distinct or not. So we are talking about unique numbers. So what comes into your mind? Yeah, hash set. So I'm going to initialize a hash set, sorry, set of type integer that takes our integers in this 3 by 3 grid, and if it contains the duplicate, then we can know because a set should contain the, and I'm gonna name it as scene, because if we have seen a number before, then we'll simply return false as set. So if this is way, else if scene dot or set dot contains grid, instead of calling grid of this all the time, I'm gonna initialize a local variable in num, just use that everywhere. num num int num. If it contains if the set contains the number, then it says that it has the 3 by 3 grid has duplicate, so we simply return false. Otherwise we'll add the number into our set. Scene dot add num. this takes care of our first condition. Let me comment the unique distinct numbers, dis, distinct numbers, and numbers should be in range 1 to 9. So this checks for the first condition. And what is the second condition? So the second condition is the sum of each row should be same. Sum of so we are going to check the sum of rows. So sum of each row must be same. So since we are going to check the sum of rows and columns and diagonals should be same, first of all let me check the sum of single row first. I'm gonna call that as int sum. So we can use this to check if this sum equal to the sum of other rows and columns. So how do we get the sum of the row? So here we have the indices. So to get the sum of a single row, we have to increment the column number. So I'm gonna type it, grid of row col. We have to increment the grid of row col +1. Similarly, plus grid row col +2. So we get the sum of first row here, so now we can check this sum, whether sum of second row, third row is equal to this. We can use it as a check. Int we can simply check check sum of rows. Okay, this is for sum of first row. Now we can simply have a condition. If uh, I'm just gonna copy this. Yeah. Uh, and for the second row, we just have to increment the row by 1. Row +1 +1, sorry, +1 +1, and we check if it does not equal to sum. Then we simply return false. Return false. Same for this third row as well. We just have to increment the row by 2 for the third row. And if it doesn't equal to sum, we return false. Now check sum of calls. Check sum of calls. How do we check the sum of calls? First of all, we just have to keep the, for first column we have to keep the column constant and increment the rows. If grid row col plus grid of, we have to increment the row +1, keep the call constant. Doesn't equal to sum, return false. And for second and third column, we just have to increment the column by 1. Increment the call plus 1, call plus 1, call plus 1. For call column 3, we just have to add column plus 2, column plus 2. And now coming to diagonals. Check sum of diagonals. How do we check it? So there will be two diagonals here. So first one will be this diagonal and the second one will be this. So we can observe that in for diagonals the row and columns are increasing by 1. So for by 1, here we have 1 1 2 2 3 3, and this for this column we are decreasing the row number and increasing the column number. So the second column, that's I'm going to type in. If rid of, sorry, let me copy from here. We have to increment both column and grid, column and row. Okay, doesn't equal to sum, then we have to return false. Copy once again. For the second diagonal we have to decrease the row number and increase the column number. My mouse is not. Uh, Increase the row or decrease the column. Row plus 2 and decrease the column. And if all of these conditions are satisfied, then simply we are going to return true. Return, sorry, return true. And this must be it. The function is almost done. We have checked it for the distinct numbers, and the range should be between 1 and 9, and checked for the sum of rows, they should be equal, and sum of columns they should be equal, and sum of diagonals. If any of this condition fails, we are returning false. Otherwise, if all conditions are true, then we are simply gonna return true. Let me run the function. Let's see if it works or not. Compilation. Okay, just a typing mistake here. Again typing mistake. Okay, again same mistake, typing mistake, integer. I have done of okay, now it works. The solution was wrong because I have done a simple mistake here. Instead of adding the I and j here, I'm just taking I and j, which will be 0, 3 and all. So that's the mistake here. I have to add row, row plus I here and call plus I. That's the simple mistake I've done. So let me submit it. I will check if it's not done. Yeah, no, it's working fine. So the time complexity, coming to the time complexity and space complexity. So here we are not using much of a space here. We have declared a hash, but the maximum size of it will be 9 only. So it will be considered constant. So space complexity will be constant. And also we are going through every 3 by 3 matrix possible in the given matrix of size row into columns. So the time complexity will also be O of row into column size of m into n. So that's pretty much it. Thank you.